chapter 4, matrices, subtopic 4.1. Okay, learning outcomes, identify the different types of matrices. Okay, and then perform operations on matrices. Find the transpose of matrix. Okay, include properties lah. So you have to know all these properties. Okay, so definition of matrix. A matrix, plural matrices of order m by n, is a rectangular array consisting of entries or elements in m rows, horizontal, and n columns, vertical, as shown below. Okay. So as you can see here, there are m rows. Okay. 1, 2, 3 up to n. Okay, so m rows, and then you have n columns, 1, 2, 3 up until n. Okay, so you have n columns. A matrix is called m by n if it has m rows and n columns, as I said just now. Okay. The matrix for which the entry is in row I and in column J is denoted by Aij. Example 1, let A equals to 5, 6, -9, -2, 3, 7. What is the order of A? So you have to take a look at the matrix and count the columns and then the rows as well. Okay, so we have 2 rows, 1, 2. Okay, or I can highlight like this, 1 row, 2 rows. Okay, and then how many columns? Okay, you have to count it, 1, 2, 3. So the matrix A is of the order m by n, row by column. So 2 by 3. Next question, if A is equal to Aij, identify A21 and A13. So for this question, okay, you have to find the entry in the second row and first column. So 2, 1. Second row, so 1, 2 here, and then first column. Okay, that's the first column. So this is the entry that we want. Okay, -2. A21 is equal to -2. And then A13, you have to focus on the first row and third column. So this is the first row and then this is the third column. Okay, so the entry is -9. So for question C, you have to find the value of A11 plus A22 plus A23. So identify which are the entries involved. Okay, so A11, okay, first row and first column, you have 5 plus A22, second row and second column, you have 3. And then lastly, you have to take a look at the second row. Okay, second row, third column. So second row, second row, and then third column, this one. Okay, the entry is here, -7. So plus -7. Can just use calculator and get the answer, equal to 1. Example 2, let A equal Aij, where A is a 3 by 3 matrix. Find matrix A if Aij is such. Okay, this is the condition given. So you know that A is a 3 by 3 matrix. So you'll have 9 entries altogether. Okay, I've listed down all the entries, A11, A12, A13, and so on. So let's focus on the first entry, A11. So in this case, A11, I is equal to 1, J is equal to 1. So, okay, focus on the first function given. Okay, so I equal to J, I less than J or equal to J. So in our case, A11, I is equal to J. So we follow the first function, I times J. Okay, so our I is 1, J is 1. So 1 times 1. Okay, and then A12, I is less than J. Still, we'll follow the first function, 1 times 2. And the third one, A13, still I is less than J. So we follow the first function, I times J. So I equals to 1, J equals to 3. So 1 times 3. Then next one, I is equal to 2 and J is equal to 1. Here, let me show you. Okay, I equals to 2, J equals to 1. That means I is greater than J. Okay, so we follow this function, I plus 2J. So our I is 2 plus 2J. J is 1. Okay, then we get 4. The next one, A to 2. So back to the first function, 2 times 2 equals 4. And then 2, 3. Okay, let me just highlight this. Okay, you can just identify first. Okay, so identify which function we're going to use. Okay, so 2, 2, 2, 3. So for this one, okay, so all this, the ones I've highlighted in yellow, will follow the first function because it fits the condition given, I is less than or equal to J. And then the rest will follow the second function. Okay, so that will be easier for us to do calculation. Okay, so 3 is 9. Then this one, I plus 2J. Wait a second. Okay, so 7. And then I plus 2J, 5. Right. Now we just have to rewrite all the entries in matrix form. Okay, so all the entries, right? So 1, 2, 3, 4, 6, 5, 7, 9, and we're done. Matrices 2m by n matrices are equal if they have the same dimension and their corresponding entries are equal. So For example, given A and B, find the values of A, B, C and D such that A is equal to B. So it is stated that A is equal to B. So then we can just rewrite that in equation form. So 3 minus A, 6, 4, 8, 4B, 2 is equal to 9, 6 minus C, 4, 2 minus 3D, negative 8 and 2. So now we can just compare these two. So I can compare 3 minus A with 9, then 6 with 6 minus C, and last one I'm gonna okay, so 8 compare with 2 minus 3D, and the last one 4B equals to negative 8. Right, so 3 minus A is equal to 9, 6 equals to 6 minus C, 8 equals 2 minus 3D, and then 4B equals negative 8. Okay, just solve all these. So you're going to get A equals negative 6, then B is equal to negative, B equals negative 2, and then for C we get 0, and then D will get negative 2. Then that's it. You have a row matrix, which is a 1 by n matrix. Okay, as you can see, there are different numbers of columns, but these matrices are all row matrix which has only one row. Okay, next, column matrix. Column matrix is a m by 1 matrix. So as you can see, you have different number of rows, okay, 4, 2 and 3 rows, but all of these have only one column. Okay, so that's column matrix. And then the next one is square matrix. So square matrix is a square matrix with the same number of rows and column. As you can see here, you have 2 by 2 matrix and 3 by 3 matrix. Okay, sorry. So you can also have 4 by 4 matrix, 5 by 5 matrix. So they are all square matrix. Okay, same number of columns and rows. Next, zero or null matrix is a matrix with all its entries being 0. As you can see here, you have no other entries other than 0. And then diagonal matrix. Diagonal matrix is a matrix, usually a square matrix, in which the entries outside the main diagonal are all zeros. So this is the main diagonal. Okay, you only have entries other than 0 on the main diagonal. Okay, outside of the main diagonal, you only have zeros. Okay, next, identity matrix. Okay, identity matrix is also a diagonal matrix, so you only have entries on the main diagonal. Okay, so identity matrix is the n by n square matrix with ones on the main diagonal and zeros elsewhere. It is denoted by IN. So you have ones on the diagonal. Okay, so 1. When you cannot have other entries other than 1. and the rest will be 0. Okay, and then lower triangular matrix. Okay, it is a matrix with all the entries above the main diagonal are 0. As you can see here, you have zeros above the main diagonal. Okay, and then upper triangular matrix is a matrix with all the entries below the main diagonal are zeros. So other than the ones I've highlighted will be 0. Okay. Now matrix operation. Okay, so for addition, we'll add corresponding entries. So 1 plus 4 we'll get 5, and then 2 plus 3 we'll get 5. Next one, 3 plus -5 will be -2, and lastly 4 plus 6 will be 10. So that's the answer. For B, as you can see here, this is a 2 by 2 matrix, and then this one 1 2 is a 2 by 1 matrix. So they are not of the same order, hence you cannot add them up. So it is incompatible. They are incompatible, you cannot add them up. Okay, and then subtraction. 2 minus 1. You get 1. And then 3 minus 2, you get 1. And then 4 minus 3, you get 1. Lastly, 5 minus 2, you get 3. Okay. So for B, you have 3 by 2 matrix here, and this one is 2 by 2 matrix. So they are not of the same order, you cannot subtract one from the other. Okay, so this is incompatible as well. Okay, then scalar multiplication. For scalar multiplication, you just need to multiply everything by -1/2 here. Okay, so -1/2 times 2, you get -1. Then -1/2 times 4, you get 2. And then -4, -5/2, 3, and lastly -7/2. Okay. Multiplication of two matrices. Two matrices are compatible for multiplication if the number of columns in the first matrix is the same as the number of rows in the second matrix. If matrix A, if the order of matrix A is m by n and the order of matrix B is n by p, then the product AB is an m by p matrix. Okay, so you get m by p. So for example, this matrix times this matrix, so you have 2 by 3 matrix and 3 by 2 matrix. So these matrices are compatible because the number of column in the first matrix is the same as the number of rows in the second matrix. Okay, and the order will be 2 by 2 matrix. Okay, the order of the product matrix will be 2 by 2 matrix. So how do we multiply matrices? So we have to take a look at the first row of the first matrix and first column of the second matrix. Okay, so first row, first column. So you'll get the first row and the first column for the the product. Okay. Right. So what we need to do is just multiply 1 by 2 and then 2 by -3 and then 3 by 2. Okay. So 1 times 2 plus 2 times -3 and then plus 3 times 2. So do the same for the rest. So multiply the first row and the second column. Okay, so the first row 1 times 1 and then 2 times 4 plus 3 times 1. Then for the second row and first column, so second row, first column, okay, -2 times 2, then 0 times -3, 5 times 2. Okay, lastly, -2 times 1, and then plus 0 times 4, okay, 0 times 4, and then 5 times 1. Now all we need to do is simplify the matrix. Okay, so this will be 2 and then some of these will be 12. So this one will get 6 and this one is 3. Question B, example B, given A is equal to 1, 2, 3, 4, find A squared. So for A squared, okay, you have to multiply the matrix by itself. So A times A. Okay, so how do we do this? Okay, just the same process. Okay, first row and first column, and then first row and second column. Okay, then the second row, first column, so 3 times 1 plus 4 times 3. And lastly, second row and second column, so 3 times 2 plus 4 times 4. Properties of matrix operations. So A times B is not equal to B times A, and then A plus B is equal to B plus A. A plus B plus C is equal to A plus B plus C. And then A plus negative A is equal to 0. Alpha plus beta times matrix A is equal to alpha A plus alpha A plus beta A, where alpha and beta are constants. And then alpha times A plus B is just equal to alpha A plus alpha B. Alpha times beta A is equal to alpha beta times A. Matrix A times matrix BC is just equal to the product of matrix AB times matrix C. And then matrix A times matrix B plus C is equal to matrix A times matrix B plus matrix A times matrix C. Transpose of a matrix. The transpose of a matrix A written as AT is the matrix obtained by interchange the rows and columns of A. That is, the ith column of AT is the ith row of A for all i's. Okay, so for example, let A equal to 3 to 0, 2, 1, 3, 5, negative 5, and 7. Okay, then A transpose is equal to 3 to 0, 2, 1, 3, 5, negative 5, 7. And if you see, take a look at B. Okay, B is 4, 2, 5, 0, 5, 7. So the transpose of B is 4, 2, 5, 0, 5, 7. Okay. Properties of transpose matrix. Okay, transpose matrices. So A plus minus B transpose is equal to A transpose plus minus B transpose. Then A transpose, okay, will be equal to A, and then AB transpose is equal to B transpose, A transpose. Lastly, K, where K is a constant, okay, so K A transpose is just equal to K times A transpose. So example 4, given that A is equal to 1, 2, B, C, and D, and then find A transpose. So for A transpose, you have to take a look at A first. A is 1, 2, so A transpose will be 1, 2, like this. Okay. Then for B, you have 2, 1, 3. So B transpose will have 2, 1, 3, like this. For C, you have 2, 2, 3, 4. So C transpose will be 2, 2, 3, 4. Sorry. Then lastly, D transpose will be 1, 3, 3, 2, 5, 4, 1, 3, 5. So for AC transpose, let's find AC first and then transpose. So A times C, 1 times 2 plus 2 times 3, and then 1 times 2 plus 2 times 4. Simplify and you'll get 8, 10. So AC transpose will be 8, 10. Or you can just use property AC transpose is equal to C transpose times A transpose. So C transpose is 2, 2, 3, 4. Then A transpose is 1, 2. So 2 times 1 plus 2 times 2. Then second row, first column, 3 times 1 plus 4 times 2. And you'll get the same answer. I'm sorry, my bad. C transpose should be 2, 3, 2, 4. So this one should be 3. This one should be 2. Okay. so we'll get 8, 10. Okay, same answer. Then let's find dB. I'll just use the property. So dB transpose is equal to B transpose times D transpose 213. So 2 times 1 plus 1 times 3 plus 3 times 3, you will get 14. Then 2 times 2, 1 times 5, 3 times 4, you will get 21. Lastly, 2 times 1, 1 times 3, plus 3 times 5. You'll get 20. Symmetric matrix is a square matrix that is equal to its transpose. So A is equal to A transpose. So if you take this for example, this matrix for example, transpose it, okay, you'll get the same thing. Okay, so the second one, skew symmetric matrix, is a square matrix A whose transpose is also its negative. Okay, so A equal to negative A transpose. If you take this for example, 0 to negative 2, 0, transpose it and times by negative, you'll get the same thing. Example 5, given that A and B, okay, if 2A minus B is a 3 by 3 symmetric matrix, determine the value of P, Q and R. So let's start with simplifying 2A minus B. Okay, I've already write it down. Okay, so just simplify this. So 2 times 3 minus 2, you'll get 4. And then 2 times 5 minus 9, you get 1. Next, 2 times P minus negative 4, you get 2P plus 4. Now you just do the same for the rest. So 2Q plus 3, negative 2, 2, 0, 2R minus P, 3. Okay, so since 2A minus B is a symmetric matrix, then 2A minus B is just equals to the transpose. So let's rewrite that in as an equation. For 1 2P plus 4, 2Q plus 3, negative 2, 2, 0, 2R minus P, 3 is equal to 4, 1, 2P plus 4, 2Q plus 3, negative 2, 2, 0, 2R minus P, and 3. Okay, you can see that I've just interchanged the rows and columns. So now we can compare the entries. So I'm focusing on the entries that have Q, R, and P. Okay, so we don't need to compare everything. Just take what we want. Okay. Okay, so 1 is equal to 2q plus 3, the red one. Okay, and then the green one, 2p plus 4 is equal to 0, and last one, 2 is equal to 2r minus p. So we have 3 equations and 3 unknowns. So we can solve all the equations to get the value of the unknowns. So for this one, q is equal to -1, just rearrange them. And this one, p is equal to -2. Substitute p in here. You get 2 is equal to 2r minus -2. So r is equal to 0. So there you go. Get the answer for Q, P and R.